What are the main components of a large language model LLM architecture? Answer: a large language model LLM architecture typically consists of several key components that work together to enable the model to learn and generate human-like language. The primary components of an LLM architecture are the embedding layer. This is the first layer of the model responsible for converting the input text into a numerical representation that can be processed by the model. This is done by mapping each word in the input text to a unique vector, known as an embedding, which captures its semantic meaning. The encoder is responsible for processing the input text and generating a continuous representation of the input sequence. This is done by applying a series of self-attention mechanisms which allow the model to focus on different parts of the input sequence simultaneously. The encoder also includes a recurrent neural network RNN or a transformer encoder, which helps to capture the long-range dependencies in the input sequence. The decoder is responsible for generating the output text one word at a time. It takes a continuous representation generated by the encoder and uses it to predict the next word in the sequence. The decoder also includes a self-attention mechanism, which allows it to focus on different parts of the input sequence when generating the output. The output layer is responsible for converting the predicted word into a final output. This is done by applying a softmax function to the output of the decoder, which generates a probability distribution over the vocabulary. The loss function is used to measure the difference between the predicted output and the actual output. The model is trained to minimize this loss function, which encourages it to generate more accurate and relevant text. The optimizer is responsible for adjusting the model's parameters during training to minimize the loss function. This is done by applying a gradient descent algorithm, which updates the model's parameters based on the gradient of the loss function with respect to the parameters. These components work together to enable the LLM to learn and generate human-like language. The model can be fine-tuned or retrained with updated data to improve its accuracy and relevance over time. The applications of LLM text generation are vast, including answering customer questions, language translation, text summarization, and many more. Depending on the company, LLM can be used to improve customer service, automate language translation, or summarize large documents.